Hello everyone, my name is Shreetan Naik. I am intern at the Sparks Foundation and I am doing internship in data science and business analytics, and this is my task number 2. So our title is prediction using unsupervised machine learning, and our problem statement is from the given iris dataset predict the optimum number of clusters and represent it visually. So let's first understand what is unsupervised machine learning. Unsupervised machine learning is a technique where model is not supervised with any training data set. Model itself have to find the patterns and insights from the data. So some examples of unsupervised machine learning is k-means clustering and principal component analysis. Unsupervised machine learning actually works like our human brain. First, it tries to find out some important features from the object and then it decides in which cluster it should be there. So let's first understand what is k-means. K stands for number of centroids and means stands for averaging of data for finding the centroid. This algorithm uses the concept of Euclidean distance. Now let's jump to our coding part. I have imported some important libraries like NumPy, Pandas, and Matplotlib. By using pd.read_csv, I am importing my dataset and I am doing df_iris.head. This is my data frame which is ready now and I am showing my data. Here we can find there is ID, sepal length, sepal width, petal width, and the species. So this is our dataset. So let's do some exploratory data analysis on the data. First, I'm doing df_iris.shape. Means I'm checking the shape of my data frame. So it's telling like there are 150 rows and 6 columns. Then I'm checking the names of columns. What column names I'm having. So there is ID, sepal length, sepal width, petal width, and the species. After this, I'm doing some basic checks like if there are some any null values present in my data by using isNull function and isNA function, and we have found that there are no null values present in our data. I am dropping the ID column here. For that I have used df_iris.drop ID access equal to 1 and in place equals to true. In place equals to true means drop that column permanently. So now my data looks like this. I have found some information about my data like it's non-null and what is the count, it's 150, and what is the data type, like it's float 64. I have described my data and in that we can find that what is the count, what is the mean, what is the minimum value, what is the maximum value. So this is our data. Then let's visualize our data. We have found here that Iris virginica, Iris versicolor, and Iris setosa. These are the three species which are present in our dataset, and the size is 50, 50, and 50 each. And then we have to find the correlation of each data. So sepal length have a positive correlation with the petal length which is 0.87. Similarly, petal width have a positive correlation with a petal length of 0.96. So this is our correlation which we have found. Here I am creating an array for first 4 columns. So now our data looks like this. Now let's build our model. From sklearn library I am importing k-means. I am declaring WCSS. What is WCSS? Within cluster sum of square. So for model building, we have used a k-means equals to k-means, n clusters is equals to I, init equals to k-means plus plus, maximum iteration is 300, and n underscore init is 10, and random state is 0. Then I am fitting this model by k-means dot fit, and here there is a inertia. So let's understand what is init. Init is the method of initialization where it selects initial cluster center for the k-mean. N underscore init is the number of times the k-means algorithm runs with the different centroids. Max iter is maximum number of iteration of algorithm for the single run, and inertia is sum of squared distance of a samples to their closest clusters. So after fitting this initial k-means algorithm, we found this elbow method, and here we can see this visualization is called as the elbow method, and we can see that the number of clusters is 3. This is the optimum number of cluster. So now we are using n clusters equals to 3, init equals to k-means plus plus, maximum iterations we are doing 300, n underscore init is 10, and random state is 0. So y-means equals to k-means dot fit underscore predict of x, which gives us this data visualization. The data visualization, in this we can see that the red color is one cluster, green color is one cluster, and blue color is one cluster, and this yellow are the centroids for our dataset. So this is iris setosa, blue is iris versicolor, and green is iris virginica, and these are the three centroids. So here our task 2 is completed.